So today what we're going to do is we're going to look at integers, which are often called signed numbers. And we've talked a bit about this. Remember that there's no such thing as a 4. You can have a positive 4 or a what? A negative 4. And most of you are familiar with the idea, but I want to go through and and formalize the concepts just to make sure that everybody knows how to work with these, because even though you're not going to be tested on this in this section, it's important that you understand it, and the more you understand now, the better you're going to be off. Okay? Now, I know that all of you have seen a number line before. Yeah. And the standard arithmetic number line starts with 0, and what happens to the numbers as you move to the right? They get higher. And the little arrow says that they go on forever, infinitely, yeah? Well, there's another number line, another part of the number line that is used when you move forward, and that is there's a left-hand side that also goes on infinitely. And on that side, you get what are called the integers, or the negative numbers. You're below 0. And to indicate that you're left of 0, we use that little negative symbol. Now, it's a mirror image of the other side. What do I mean by mirror image?
It's exactly the same.
Well, it's reversed, right? So if you see that it goes 1, 2, 3, this one goes 1, 2, 3, but the opposite direction. Okay? And to indicate that they're on the left of 0, we just put those little minuses in front of them. Now, for convenience, we call it negative. But that little minus actually means the opposite of. So, negative 2 is really simply the opposite of what? 2. The opposite of 2. And the reason they're opposites, because what happens when you use opposites? What do they do to each other? They eliminate each other, right? Okay? If I give you $5 and take away your $5, you have nothing left. No dollars, right? I would never give you $5 in the first place.
That's rude.
Who would kid? All right. I'm a teacher. I don't have $5 to be giving away. All right, here we go. So the opposite of. All right? But for convenience, we usually think of them as being negative on this side and positive on this side. Now notice there's one number that has no opposite. What is it? 0. There you go. That's all right. It's fine. We're doing just group participation. So it is neither negative or positive. It has no sign because it has no value, right? Can't have the opposite of nothing. Right. It means literally nothing. Okay? So everything else has an opposite. Now I want you to notice that as the numbers get bigger on the left-hand side, what's happening here is they're getting more negative. In other words, smaller. Even though the numerical value is getting bigger, because it's negative, that means it's really getting smaller. So if I had negative 24 and negative 3, which one's actually smaller? Negative 24. It's because it's negative, it's going to, as the number gets bigger, you're actually getting smaller. Okay? All right. Now, when you're dealing with positive and negative numbers, you can think of the number line anytime you get stuck, because you can use it to combine and do and multiply all kinds of things that you would normally do in mathematics. But we really want you to start thinking about the algorithms. And remember, you know that word algorithm simply means a method, the way to do it, right? So, for example, when you're adding two numbers and you write them up and down like this is called the column algorithm for addition. You could also write addition like this, right? Okay. So there are different algorithms or methods to use. So you could rely on the number line if things are simple, but what if I have negative 432 and something? Do you want to draw a number line with negative 432 on it? No way. So you don't want to rely on it. But we are going to I'm going to show you how and why, because you were talking about why does that work that way, and I can demonstrate that with the number line really easily. Okay? All right. So the first things I want to talk about when we're dealing with the number line is I want to talk about combining signed numbers. Combing. Oh, that's combing. Yeah, you don't need to comb them. Combining integers. And again, integers just means signed numbers, right? And combining takes the place of add or what? Subtract. Because sometimes things that look like subtraction, you end up adding the numbers. And sometimes things that look like addition, you end up subtracting the numbers. So you can't really think of it as add and subtract anymore. That's why we use combining once we start thinking in integers. And all of algebra, you need to think of integers. Okay? All right. Now, there are a couple of rules that are to do this. And they're really easy to understand if we go back to the number line. So let's just draw our number line. I'm just going to draw a small one. 2, 3, 4, 5. 2, 3, 4, 5. Now, they should be perfectly symmetrical, but, it doesn't always work out like that. It's fine. Now, let's think about combining and what happens. Okay? Say, for example, I have 2 plus 3. Now, both of those are positives. And the first one is positive. We know it's positive because if you don't have a sign, you can assume it's a positive, right? That's the only sign you get to assume. And it has to be only the very first number or letter. You can't, from then on, you have to have pluses and minuses between them. Okay? Now think about it. Where is positive 2? It's right there, right? Okay? And this says I'm going to go positive 3. Well, positive means to the which direction? Right. To the right. How many units? 3 units. So 1, 2, 3 lands me where? At 5. Okay? Now, what if I have negative 2 minus 3? Both of these are what sign? Negative. So where's negative 2? Below 0, 2 places, right? And then I need to go negative 3 from there. So negative 3 means not to the right, but the what? So I'm going to go what? Left, how many units? 3. And where does that land me? At negative 5, right? Yes.
So that's negative 2 plus negative 3, right?
Yeah, it's just negative 2 and negative 3. We're combining them.
Yeah.
Don't think of it as plus or negative. That's a horrible shortcut to use. Trust me. Just think of it as it's a negative 2 and a negative 3.
I mean like plus positive. Sorry.
No, there's no positives here, right?
No, that's the one.
Those are both positives. Yeah, so they both.
You're combining them, right? So that means addition.
Well, we'll get there. Hold on a minute. Okay? Now, what do you notice about both of those? That even though the signs were different, 2 and 3 combined, both made what? So what did I do to the numbers? I added them, right? Right? Don't you add 2 numbers to make 2 and 3 to make 5? Now, but notice that the 2 positive ones gave me what kind of 5? And the 2 negative ones gave me what kind of 5? A negative 5. And that's where the rules for combining come from, one of those sets of rules. Okay? And that first rule is this. When combining, first rule, if the signs are the same, and remember, the same means they're both positive or they're both what? Negative. And you just look at 2 numbers at a time. You don't usually add 16 numbers by looking at all 16 at one time, right? You usually do them in chunks of 2. Do you agree? Okay, so think of that. If the signs are the same, then what we're going to do is, first, we're going to keep the sign. Notice that both of these were positive and our answer was a positive. Both of these were negative and our answer was a negative. So we keep the sign. Whatever sign they have, that's the sign your answer is going to be. Okay? Now, second rule. Second part of it is, and what you'll do is add the numbers. So keep the sign, and add the numbers. So here, positive and a positive made a positive, and 2 plus 3 is 5. Negative and a negative combine to make a negative, and 2 and 3 make 5. No, yep. Okay.
Didn't you say the other day that
That,
two of the same
that.
is a positive?
different operation. That was multiplication.
Oh.
Yeah, and that's why we need to go through this. So we're talking about combining here, guys, right? Not multiplication. The rules for combining are different from the rules for multiply and divide. Thank you for that, though. That's a good thing. Okay? All right.
The rules for combining
The rules,
different
yeah.
from the rules for multiplication and division.
Exactly. Okay? Now, let's look at another example, okay? So that we can build the second rule. Ignore all that stuff up there, would you, please? All right, here we go. So here's the second one. Let's say we start off at 2, and I got 2 and negative 3. So 2 minus 3. So the 2 is what sign?
Positive.
So that's right here, right?
Yes.
But then we're going to go negative 3, which means which direction?
Left.
How many units?
3.
So 1, 2, 3. And where do we end up?
Negative 1.
So there's your answer. Okay? Okay. How about if I have negative 2 plus 3? I'm going to start at negative 2, and I'm going to go where? To the right 3 units. Yeah. So 1, 2, 3. Where does that land me?
1.
What kind of one? The positive one. And I'm putting the pluses and minuses in. You have to put the minus. I don't really need the plus, but for right now, for effect, I'm going to write it because that's what we're looking at, right?
Right there.
Okay? Okay. All right, you can put it there if you want to. It's all right. Okay, now, let's look at what happened. This one had a minus, and we ended up taking 3 minus 2 to get the 1, which sounds right? We subtracted. But what sign was in between these two? But we didn't add 2 and 3, did we? We subtracted. So that's what I'm talking about. Sometimes things that look like addition turn out to be subtraction, and things that look like subtraction turn out to be addition. So you can't look at things as pluses and minuses being added and subtracted anymore. You have to think of them as being the sign of the number. And it's that combination of signs that tell you what to do. Guys? All right? Do you have a question?
No.
Okay. So let's write the second rule. Second rule. The first one started off with if the signs are the same. So what do you think the second rule is going to start off with? If the signs are what? Different, exactly. Does anybody remember what the answer is called when you subtract? Do you remember what the answer is called when you do a subtraction problem? It's called a...
Answer.
When you add, it's called a sum. When you subtract, it's called a... It's pretty clever. A difference. And where do you think that word comes from?
Different.
Because the signs are different. All right? So, okay? If the signs are different, then what you're going to do is you're still going to keep one of the signs because your answer has to be either positive or negative. Does that make sense? But you're going to keep the sign of the larger. Now, so here, 3 is bigger than 2, isn't it? And the 3 was negative, so your answer was also a what? Negative. Here, 3 is bigger than 2, but what sign was the 3?
Positive.
So your answer is also a positive. Make sense? In other words, one of the numbers is going to be more positive or more negative than the other. Okay? Now, in reality, a negative 3 is smaller than a positive 2. So, it's just the number you're looking at. Because in reality, a negative 3 is smaller than a positive 2. But it's just the number value. It's called the distance from 0 is called the absolute value. Have you ever heard of that before? Okay. Absolute value just means the distance from 0. And negative 3 is further away from 0 than a 2 is, isn't it? Okay. So you'll learn about the absolute value sometime. So keep the sign of which one? The larger. And then 3 and 2 will only combine to make a 1 if you add them or what? Subtract them. So if the signs are different, you end up subtracting the numbers. Okay? That's it for combining. Those are the two rules. Yes? Oh, you're going to have a ton of examples. All we're going to do from this point forward is I'm going to write some examples. We're going to work a few together. And then I'm going to put some examples. You're going to do them on your own. And I'm going to call you to give you the opportunity to answer for yourselves. Okay? So everybody realizes that everybody has an equal chance of being called on, right? So we better know what we're doing. Yes? Okay? Can you have your notes in front of you to tell you what to do? Yes. But you still have to do it, all right? Okay. So let's just go through a couple together. First of all, say we have -5 plus 7. Okay? I know I'm combining because you don't see any multiplication or division symbols, right? If it's not multiplication and division, then it has to be combining. Because remember, we went through this before. The first and most important question you can ask yourself is what operation you're being asked to do, right? Okay? The next one was with what kind of things. Remember us going through this? So, if you don't see multiplication or division, then you must conclude that you were doing what? Combining. Get it? Okay? And that's the easiest way to know that you're combining, is to see that it's not multiply or divide. Because remember, multiply and divide have their own symbols. If you don't see any, then you know you're combining. Okay? And what kind of things am I combining? Don't say numbers. Say their fancy word that I just taught you. They got an I in it. Maybe integers, right? Or you could say signed numbers. It means basically the same thing. All right? I'm happy either way. All right?
Would that equal...
Hold on a minute. Come on, let's follow through. But keep it in mind. Okay? All right. Now, the third thing is we have signed numbers, so I need to determine what sign my answer is going to be. Anytime you're working with integers, if you don't write the sign down first, then you're just asking for trouble. Okay? Because I can't tell you how many tests I've graded in calculus and beyond where students have the correct number but the wrong sign. And let me tell you, it matters. Because would you rather me give you $100 or would you rather give me $100? Yeah. So would that be to have a positive? So that's the difference between a positive 100 and a negative 100. Positive means you're getting it. Negative means you're giving it away. Yes. Mm-hmm.
Two things. One, how do you tell if it's multiplication or like?
Well, remember we went through those rules for for multiplication. So it's like 4A, 4 times A, 4 bracket A, right? All of those. Okay. So if you don't see any multiplication, you know it's combining. Okay?
So like from now on, when we like take a test, does it always have to be like the number, the answer? Does it always have to have like positive or something on it?
You should get in the habit of doing it. Yes.
Always.
Yes.
Forever and
It's not
ever.
going to hurt
Until you're 13.
until university is done.
How fun.
Yeah. Okay. So always do the sign, and then you're going to combine the numbers. Okay. Now in this case, are my signs the same or different?
Different.
Yeah. All right, guys. So what's the sign of the 5? What's the sign of the 7? So if the signs are different, I need to keep the sign of one of them. Which one in this case? The larger one, which is the 7, right? So my answer is going to be a positive. And since the signs are different, guys, what am I going to do to the numbers? Subtract them. So 7 minus 5 is positive 2. Now, is the 2 critical, the plus in front of the 2 critical? No. But if you're new to signs, or if you've learned signs before and you make lots of mistakes with them, then write the pluses. It's not going to kill you, and it's not going to be wrong. Okay? All right?
I thought you combined.
Okay. I am combining. But combining means either add or subtract. In this case, I'm combining them. The signs are different. So I keep the sign of the which one? The larger one. And then what do I do to the numbers? Subtract them. It's good?
Subtract, yeah, so you subtract,
So 7 minus 5 gave me the 2, right?
but then you're putting it backwards.
Now, it doesn't matter. When you do subtraction, you always take the larger one minus the smaller one. Okay? All right. Here we go. Let's look at another one. Say I have 12. And let's do negative 12. Negative 12 minus 8. Okay? First off thing I need to know is what operation is indicated. Do you see any multiplication or division?
No.
That means it has to be combining. Make sense?
Yes.
It's not those two. It's got to be the other one. So it's combining. In order to combine, the first thing I need to do is look at the what? Signs. What's the sign of the 12? Negative. What's the sign of the 8? Negative. So are the signs the same or different?
Same.
The
So
same.
you add them.
If the signs are the same, that means I'm just going to keep the sign.
Yes.
So they're both negative, so the answer is also going to be what? Negative. And then what do I do to the numbers? Add them together. 12 plus 8 gives me 20. So my completed answer is negative 20.
Wait, so if the signs are the same, you add them. But if the signs are different, you
Exactly. Okay. All right.
It's easy. Wait, what?
Okay. That's all right. We're going to go through several together, and you've got your notes in front of you. All right. Here we go. Say we have 17 plus 2. Now this one should look very familiar, but we're going to do it with signs anyway. Okay? Is it multiplication or division? Just to show you that you've been using these rules forever and you just haven't realized it. So that means it's combining, right? So when it's combining, we need to look at the signs. What's the sign of the 17? That's the sign of the 2. So the signs the same or different? The same. So my answer is going to stay a what sign? Positive. And then I'm going to do what to the numbers? Add or subtract them? Add them. So 70 to 2 are 19. So you see that you've been doing this anyway, but you just didn't realize that because you've been stuck with only 2 different sets. You've had places where the signs are the same, they're both positives, or where they're different, which is what the definition of subtraction. Okay? So you've been doing it anyway. Okay? You just didn't know it yet. And you didn't have all those negatives added in. Okay? How about negative 2 minus 234? Who cares? Right? Just trying to make it more interesting. So, first thing we need to do is what operation we're dealing with?
Negative minus.
Combining. And I know it's combining because it's not multiplication or what? Division. Okay? Just think about, this is the thought process. If you're wondering how to do these, this is the way to the thought process, right? First, what operation is it? Okay?
So does multiplication always
Yeah.
have to have...
Yeah. Yes, it always has to have some kind of symbol, or it has to be a number times a letter. Huh? No, I was trying to get her not to move forward without me, but I realized that she was asking a different question than the one I thought she was going to ask. So sorry. Sorry about that, Nene. All right, so yes, multiplication is always going to have some symbol to be multiplication, right? So like if it was multiplication, you might have something like this. How do I know that's multiplication?
Because the bracket
The number is right in front of the bracket? Yeah. Or you may have, if it's division, you would see it written like this. Because remember, we did learn before that the fraction bar is simply another way of writing what operation? Divide. Or, if they're both in a bracket?
No, what if it doesn't have a bracket?
Okay, well then it's going to be combining.
Okay.
Because it would be like this, right?
Yeah.
Yeah? Okay. There you go. Now, all right. So we're combining these two. So are the signs the same or different?
Same.
So if the signs are the same, I'm going to do what with the sign? Keep the sign. So the answer, they're both negative, so the answer was also going to be negative. And 2 and 234, I'm going to do what? Add or subtract them? It clearly says subtract right here. Doesn't it? So I'm going to subtract them. Yeah, there you go. It does not say subtract right there. I'm sorry, guys. You guys are so trusting. I'm sorry. But because the signs take over, we don't think of that as subtract. We think of that as the sign of the 234. And if the signs are the same, I do not subtract. I what? Add them.
Add, right?
Yes. Okay? I'm sorry. I did that to you on purpose, though, because I need you to see what's going on. So it looked like it should be subtract, but we actually added because the signs are the same. There you go. Sorry.
So you add it.
So we added the numbers.